All right, guys. Good Tuesday morning. You hopefully did the first part of the lesson, and now we're going to look at what we call unit conversions. And that's taking one rate, like miles per hour, and converting it into a different rate, meters per second. Now, I like miles per hour. Like, I can think that way. We think of that a lot with driving and speed and all. But in science, a lot of times you do with meters per second. And so, how do you convert the speed of a car in our normal thinking to scientific thinking? Well, that's what we're going to be doing today. So, one example of this would be 15 miles per hour. Okay, so I can that's a slow moving car or a fast bike down a hill. 15 miles per 1 hour. Okay, and remember that is a unit rate because you have two different units and you have the denominator being one. So, you had to do that yesterday, convert it into that. But we want to get it into feet per second. We want to have the units feet and seconds. Okay, so we want to go from here to here. So we're going to have to use what we call unit conversions or dimensional analysis to do that. Okay, I have to know a couple things first of all. What's a bigger unit, miles or feet? So 1 mile or 1 foot, what's bigger? Well, obviously a mile is bigger. And this is what I'm thinking off to the side, kind of in my mind, and I'll give you some other conversions that you need to know. There are 5,280 feet in 1 mile. Okay? There are 5,280 feet in 1 mile. Okay, I got to know that because I got to be able to convert from there to there. But I can also say, and I think it's blocked here, I can also say 1 mile is equal to 5,280 feet. You notice it's the same fraction, but it's a reciprocal of each other. The reason I write that down is because sometimes I use the top one, sometimes I use the bottom one. So here I have both. Okay, then I need to know how many hours, what's bigger, 1 hour or 1 second? So obviously a second is smaller than an hour is bigger than a second. And I'm going to have to know two conversions. I'm going to write them down here. 1 hour is equal to 60 minutes, and then 1 minute is equal to 60 seconds. Okay, so I'm going to have to know those two. I can come up with two fractions. It's almost like I put this ratio word form, 1 hour to 60 minutes or 1 minute to 60 seconds. So the two fractions I can come up with, and I'm going to draw these all out, and then I'll show you how to work this problem out. But I can write one as 1 hour over 60 minutes. Or I could say 60 minutes over 1 hour. Oops, 1 hour. Okay, I could say either one of those from that fact. For the 1 minute and 60 seconds, I could do 1 minute over 60 seconds. Or I could say 60 seconds over 1 minute. Okay, either one is accurate. They're reciprocals of each other, but they're all, by the way, these are equal to 1. These are equal to 1. And that's good because we're going to be converting, multiplying by 1. So that's using the identity property to convert from one unit to another. Okay, so I'm going to erase these right here. And I'm just going to put these facts down here. 5,280 feet is equal to 1 mile. Okay, so now this is what I'm going to do. All right, I'm going to go from 15 miles per hour to feet per second. And so I'll rewrite that over here, 15 miles, 1 hour. Okay, I want to get to the feet per second. So you have to either go from miles to feet or hours to seconds. Don't try to do both at the same time. So how do I go from miles to feet? Well, I'm going to have to think of this fact right here. 5,280 feet equals 1 mile. That's the fact I'm going to have to know. So using that, okay, I have this 15 miles per 1 hour. I'm either going to use 5,280 feet over 1 mile, and the spacing on my board is not going to be great. So I apologize for that. Well, we'll just deal with that. Okay, so I'm either going to use this fraction or I'm going to use a reciprocal. So you're like, well, which one do you use? Does it matter? It does. Because just like with numbers, you know how you can cancel out like 10 over 5? I can cancel out units if one is in the numerator and one is in the denominator. So I can do this. I can literally cancel out the miles, which is what I want because remember, I'm trying to go from miles to feet. And guess what unit I'm left with? Feet. So this is the fraction that I want to use because the units will cancel out. Miles and miles. So if I got the reciprocal of this one, then I would have ended up with miles and miles and feet, and nothing cancels out. So I'd end up with square miles over feet, which it's accurate to say, but it's really confusing to use. Okay, so I got to feet, and I guess I could cancel these out. I got to feet, but now I have to go from hours to seconds. So I'm going to use these two facts right here. So first I'll go from hours to minutes, okay? Hours to minutes. Now, I could either say 1 hour over 60 minutes or 60 minutes over 1 hour. So which one am I going to use? I'm going to use, stay quiet boys, I'm going to use 1 hour over 60 minutes. Now, why in the world would I use that? Well, because, stay right there, T. Because I have hours in the denominator and the numerator, and they will cancel out. If I use the reciprocal, I would not get those units to cancel out. And then the last conversion, stay quiet. The last conversion is going to be from minutes to seconds, okay? So I'm going to use 1 minute is equal to 60 seconds. And I'll put the S there because a lot of times in signs you see S, 60 S. Okay? Why did I do that? Because the minutes cancel each other out. So I end up with feet in the numerator and seconds in the denominator. And that's exactly what I wanted. That's the kind of dimensional analysis I use. But look at the numbers. 15 times 5280 times 1 times 1. And then 1 times 1 times 60 times 60. Okay, that could be a problem. You need to stop talking, buddy. Stop. Yeah. Sorry, my son's here now. Okay, but anyway, instead of doing that multiplication, why don't I do some cancellation? Why don't I cancel some common factors? So let's look at it. Look at the 15 and the 60, right? Can I cancel those out? Yeah. 15 goes into both. So 1 time, 4 times. So I just knocked out a 15 and brought a 60 down to 4. Okay. Then I can go, here's kind of a cool one. I can go 60 and 5280. They both have 10 in them. So I'm going to cross out both of those zeros. And then 6 and 528. 6 goes into 6 once. 6 goes into 528 88 times. So that just knocked that number down tremendously. And then you guys hopefully can see, look at the 4. The 4 and the 88. So 4 goes into 4 once. 4 goes into 8 22 times. So look at what I'm left with. What's 1 times 22 times 1 times 1? That's 22. That's very nice. What's 1 times 1 times 1 times 1? 1. So I end up with 22 feet per second. Right? I have the feet unit and the seconds unit. That's the unit conversion. So 15 miles per hour is 22 feet per second. That's how you can convert it. That's one of the unit conversions. Now I know this is pretty tough because maybe this is the first time you've done this, but we're going to do another problem. And these, by the way, are a little bit, this one's on the tough side because you had to do multiple conversions. But let me give you another one that might be a little bit easier to digest. And I'll try to write it toward the top so you can see that work. All right, this time I'm going to convert 5 centimeters per second. So 5 centimeters per 1 second. And I'm going to end up converting that to meters per hour. I want to get meters per 1 hour. Okay, so I don't know how many meters, but I do know it's over 1 hour. All right, so I want to go from here to there. Okay, the facts that you need to know, I'll write down here. There are 100 centimeters in 1 meter. So you should know that too because that's going to help you out in science anyway. 100 centimeters in a meter. And then there are 60 seconds in 1 minute and 60 minutes in 1 hour. Now, how in the world did I get these conversions here? Well, I'm going to have to go from centimeters to meters. So that's the conversion right there. And then I'm going to go from seconds to hours. And I use 2 conversions there. You can technically use 1, but I think the cancellation gets a little bit harder. So what I want to see on your homework is that you write the conversion. So you write what fractions you're using to convert. Okay, so I'm going to start off going from centimeters to meters. Okay, so here's my fact. So do I multiply by 100 centimeters over 1 meter or 1 meter over 1 centimeter? Well, if I do 1 meter over 100 centimeters, which is the way you want to go through it, what happens to the centimeters? What happens to the unit up top and the unit down low? They cancel each other out. And I am left with what I want, meters, right? That's what I want. Okay, so I'm done with the conversion of the distance, centimeters to meters. Then I want to go from seconds to hours. So I'm going to first go from seconds to minutes, which is this conversion. So do I use 1 minute over 60 seconds or 60 seconds over 1 minute? It should be 60 seconds over 1 minute. Okay, because guess what happens to the seconds? They cancel out. Now I have to go from minutes to hours, and I'll erase this because this is our goal. I don't want it to get in the way. So should I use 60 minutes over 1 hour or 1 hour over 60 minutes? I'm going to use 60 minutes over 1 hour because the whole goal is to end up with hours, right? So that means we have to cancel out seconds and minutes. So the minutes will cancel each other out. And guess what unit I'm left with? Hours. And that's what we want. We want meters per hour on this problem. Okay, so I'm done with all the units and the fractions I have to use. So now I'm going to simplify. Okay, I'll deal with the 5 and that 100. So 5 goes into 5 once. 5 goes into that 20 times. And then I could do either these two, the 60 and the 20, or the 60 and the 20 over there. 20 goes into 20 once, 20 goes into 60 3 times. Now, really your goal is to get the denominator to equal 1 because that's the easiest way of doing it. So what's 1 times 3 times 60? That's going to get me, I hope this is right, yeah, 180, what's our unit left up top? Meters over 1 times 1 times 1 times 1, 1, and then what's the unit down here left? Hour. So 180 meters per hour. So 5 centimeters per second converts to 180 meters per hour. So that's what we're going to get on this problem right here. Okay, the conversions you need to know, I'm going to give you a couple of them, and then I'll see how you do. There aren't many problems of this type, but I want to see your conversion factors. I want to see your fractions, and then how you convert those. And sometimes you will have to divide by a number, so that's okay. But the conversions, you also need to know 1,000, and that's not the right spot, 1,000 meters in 1 kilometer. So that's one you have to know. And then you also need to know 1,000 millimeters in 1 meter. And I think there was one more, yeah. 16 ounces in 1 pound. So 16 ounces for 1 pound. Okay, so you need to know all 3 of those plus the ones we already dealt with, and either use, for example, 16 ounces over 1 pound or 1 pound over 16 ounces, and then you can do those conversions. Okay, your homework. And again, if you have questions, please ask. I'm more than happy to help. But it's going to be 19 to 24 all. So numbers 19 to 24 all. And that's going to be on page 278. Page 278. Now, if you guys think this, don't touch that big guy. If you thought this was too intense, My middle son Titus has been watching this whole video as I record. He's been doing a great job, but we'll go ahead. He's been watching it, so if he can watch it, so can you. But if you have questions, please let me know. I'm more than happy to help. All right, take care, guys.